Welcome, everybody. Nice to see so many of you here, and welcome to the TUE, to the final presentation of TU Ecomotive. We're really glad to have you here, because this is quite a special day for us. The 11th of October, 1 year ago, was the first time we presented our concept to the old Ecomotive teams. They completely burned our idea to the ground, so here we are with a completely new idea, and we're really excited to show it to you guys. We prepared Penning. He's an old team manager of TU Ecomotive, and he will tell you how important student teams are. Our sustainability manager. Then I will take over again to guide you through the process of how we actually built this car. And of course, the moment you've all been waiting for, we will actually go and see the car and of course have a drink together. But first, I want to introduce you to our team. You just saw us here on stage, but this is our team picture. As you can see, we're quite a diverse group of students. We have master students, bachelor students. We have, well, students from many different nationalities. We have students from different schools, from HBO, from VO. Yeah, a really diverse group, and we've really grown to a friend group in this year due to all the effort we put into this project. And we also would like to show you where we actually came from, because we're, of course, not the first Ecomotive team. So we prepared a little video for you to give you a look into our history and show you some of our previous cars. Yes, it's of course nice to know where we've came from. And because of that, we invited an old Ecomotive member to actually give a talk about what you could do after Ecomotive with your experience. So I would like to ask Hans Penning to the stage, and he will tell you a bit more.
Yes, thank you. Thank you. Yes. Great. Wow. Is it working? Yes? No? Okay. No, then it's fine. Yes, I'm Hans, and I was the team manager in 2014, and that means that I was standing on this exact same place 10 years ago, 10 years already. And when I was preparing for this presentation today, I was thinking it's cool that they invited me here on stage and tell me something about what I did, but I didn't really understand why it was relevant. But when I continued thinking about it, it was actually I was at this place 10 years ago, and what I saw was that people around us didn't always understand why we were doing this. We were pausing our study for a year or maybe longer, and they thought, okay, maybe you do it for fun, maybe you do it because it's just nice to not study. But it actually is proven that it was very relevant for all the things that I did after. And all the things that I did, I can tell you a little bit more about it. This was the car that we had, and this is actually not our team, this is a team after, but this was our car. And the thing is, with building a car like this, it's actually very close to building a company. So you have sponsors. These sponsors are actually like clients, and they are suppliers on the same time. You have a team that you have to manage. But this team is not paid. And when you go to your job, then you know, okay, you will get paid, and that's maybe the reason why you show up the next day. But for most of the people here, they only show up because they want something to achieve. So they want to achieve something. They all have the same goal, and that is building this car. And having the same goal, working towards that goal, and really make something out of it is something that I really learned during the student team. And that was one of the main learnings that I've got, and I think that's also the thing that drove me to the next thing that I did, and that was Ember. We had an electric car sharing company, and in the end we had around 600-700 cars driving around in the Netherlands. And the thing that we learned there was that all the relations that we have built during our student team were very relevant for the years after, because in this team there were people from our student team. I think there were 4 people from our teams that were working inside the company, and these were the best employees because we were all aligned on the same mission. And our sponsors from back in the days became our clients. So we had really, I think, 6-7 clients at a time that were sponsors during our ecomotive time. We used the network, we used the relations that we had to build a company and have our first clients there. So building these relationships, keeping them, and have them as people that you can call and can ask for help is really something that's very relevant for the coming years. And I think that it is also the message that I want to give also to the parents here, that they are really spending their time well on building a car like this and doing a project like this, because it will definitely help them with all the things that they are going to do. And after Ember, because it sold after a few years, and we built it Nipol, and Nipol is a company that we are creating the best digital employee that is going to take all the annoying tasks away in your job. And that's a very big ambition. That's a really big goal that we want to achieve. But then we use the learnings that we got from the student team to really motivate the team to a goal that is very unimaginable, that you think of something that is only achievable in a few years. But we're building it today. We try to build it with a team and get the motivation in to build something that is something that seems to be impossible. I think that you can be very proud of the team that is sitting here. I think building a car in 1 year, that's hard work. It's a lot of hard work, but they managed to do it, and I think that's a great achievement and really great to what they can show today. Yeah, I had to keep it a little bit short, so I think I keep it here. But this is some learnings that I have had in the student teams the last few years. So yeah, give the word to you.
So yeah, thank you so much, Hans, for these nice words to our team and also the insights that you shared to us. We're also happy to know that you were still motivated after ecomotive, and that you kept doing great things. So yeah, another applause for him. So yeah, I am Eduardo Luna, I am the business manager, and I am the one behind the story or the concept of this car. And before actually introducing to the concept, I'm going to show you a video so that you can be on the same page as us.
A growing population, growing prosperity, growing needs, leads to scarcity. Change is inevitable, and TU Ecomotive takes on this challenge. We built a concept car to inspire car manufacturers to push the limits by showing them how. Stop wasting millions of materials. reduce, reuse, rebirth. Ride like a phoenix.
So yeah, I hope you like the video as well as we did when we first saw it. So well, now we move to the concept, and of course, as with every year, what we try to do is to show with our concept cars that circular economy is possible within the automotive industry. So well, now let's start talking about our concept. So indeed, cars are the ones bringing us here, and among the people here, if I had to tell you how many cars there are on the European roads, I guess that knowing that there are already 252 million vehicles is already shocking. However, what's more impactful is to know the forecast for the next years. So where there are already 6 million electrical vehicles on the roads, the plan is to register 30 million more in the next 5 years. So as you may imagine, car manufacturers would require enormous quantities of raw materials to satisfy the expected demand. And that for us was actually a concern. So for example, when you take into account that the European automotive industry is already responsible, for example, for the consumption of you might think of two scenarios, either facing a scarcity of materials or depending on third countries to actually get those materials. So we had that concern, and when we were thinking of a concept car a year ago, we were lucky to find some regulations whose goal was actually to develop a circular strategy within the automotive industry. To our interest, we found out that manufacturers from 2030 onwards are forced to hit the recycling content of 25% of recycled plastics, of which 25% of that percentage must come from a closed-loop treatment. So that is to say that a 6.25% of plastics from an old car should go back into a new car. But when we were taking a look at these numbers, we actually wondered if this was significant. And consider with this, that with this 6.25%, you need around 16 cars to get the plastics from one car back into a new car. And the other point that we found interesting from the regulations is that what happens with the other materials? There are a lot of materials involved in the production of cars whose usage is still quite high in the industry, and they are not even mentioned there. So as you may imagine, when we took a look at the proposal, we thought it wasn't ambitious at all. But ironically, we found out that policymakers and car manufacturers had some clashing opinions on this. And what is the dilemma behind it? Well, basically, while policymakers are opting for a circular strategy that goes hand-to-hand with plastics recycling and a closed-loop treatment, car manufacturers actually had some concerns about it. And why is it so? Well, basically, they say or they point out the fact that to reach such numbers in recycled content, you need further innovations in the recycling industry to actually recover some quality in their materials. That also goes hand-to-hand with the fact that in order to ensure that quality recovery, you need numerous workers to further disassemble a car so that it can go to a shredder. And besides that, there is a problem with the batteries. So it is already a complex component to be recycled at a larger scale. So we had these concerns in mind from the manufacturers. We had also our opinion on the proposal, and we wanted to challenge ourselves to find a way in which car manufacturers could solve those issues and even innovate further in the industry. So the focus for us had to be the end-of-life process. And what a better way than actually taking a journey to a dismantler. So we did so. Some time ago, we went to a dismantler, we had a tour there, and we talked to the people responsible for dismantling the car. And what we found out was impressive. So for example, you can take a look at the first two pictures. There you see the final product. And that is basically what goes to the shredders. The problem here, as you can see, is that the automotive industry is concerned about the quality of their materials. And Well, the car still needs to be further disassembled, and if you can take a look at it, the design and the structure of the car is in such a complex way that actually components are made of, are intertwined and made of different materials that shredding one huge part of it in one go is almost impossible. Besides that, you can take a look at the last picture. You see there some batteries contained well, they are stored in a container. And what we heard there is that right now we can easily store fuel tanks. But the problem is that in the next 10 years, the batteries will be the next fuel tanks. But already storing some batteries, 8 batteries actually, is already a problem, an expensive process. And recycling a battery is even worse, given that it is dangerous to recycle. So for us, with these manufacturer concerns, our opinion on the proposal, and the problems that we found out at the dismantler, we had to come up with a solution for the car manufacturers. And what a better way to say that we found a solution to it than Jo is explaining this, who is our sustainability expert. So here you have it.
Thank you, Eduardo, for giving such a lovely introduction of what the problems is we're trying to solve. So first off is, how are we going to make a car that's made to be rebuilt? There's 3 key components to this: the monomaterial approach, the layered design, and the durable batteries. Let's start off with the monomaterial approach, meaning that you use one single type of material for each component in the car. This, what you see now is, as Eduardo showed us, that a lot of materials are really intertwined into the cars, making them really time-consuming to extract, costly, and they often result in a lower quality recycled products. So by using the monomaterial approach and simplifying the process, we can more easily extract the components and recycle them to a more high-quality product. This goes also hand in hand with the layered design, which I'll tell you a bit more later about. How do we see this back in Phoenix? For example, we use one type of steel through the entire car. For the other metals, we try to reduce them and else group them together so it can be easily extracted in one go. And there's, of course, the plastics. Plastics are notoriously difficult to separate once they have been shredded or intertwined with each other. So what we've looked here is, how can we use, for every component, still use the plastics which are needed to make it a structurally sound car, while also simplifying the process for this. This also goes on to my next point, the layered design. The layered design goes hand in hand with the monomaterial approach, since it allows us, during the recycling process, to extract one layer of the car, meaning one material of the car, recycle it, and go to the next car, as can be seen in this car. So every time you go to the next car component, you extract one type of material, recycle it, and go on to the next one, allowing for high-quality recycled products to be extracted from the car. But unfortunately, not all components are recyclable. Take, for example, batteries. They have to be a complex component made in order for them to work. Think of all the lithium that has to be involved in that to make it work. And it's also nowadays going to be a very important resource. You see a lot of electric batteries being placed in home health applications. You see a lot of grid storage. So it's a resource which is also very limited, and we should be spend it very wisely using nowadays resources. So we looked, how can we implement the batteries in a better way? And we found out that around 82% of the car trips made in the Netherlands are less than 25 kilometers in distance, meaning that you nearly never need the full range which you always want to drive, for example, to work. So what we found here is a solution. Why do we not always make a battery pack which you can always use and a battery pack which you can extend? For this, we introduce the stationary battery pack, allowing us to drive a standard range of 130 kilometers, meaning you can do your everyday job very easily, and you never have to worry about if you have a full tank anymore, if you can still reach home. But for example, when you want to drive on holiday, we use the removable batteries, allowing us to extend the range up to 220 kilometers. So just plug it in and just drive off to your holiday. No need to worry about any range anxiety there then. But what do you do when you donate them? Just take them out, and you can use them, for example, for storing excess green electricity, or use them as a home battery. So there's many options to be used depending on what is your own situation. Now, I've been telling you a bit about what the solutions we've been implementing to make a car that's been rebuilt. But how does this all come together in the environmental impact? We, of course, at ecomotive strive to make a sustainable car. So what have we achieved this year? As Eduardo was telling you a bit more about the closed-loop recycling rate, so transferring material from one car to another, we were able to achieve a staggering 75% reduction in material consumption from the car, meaning that you now only need the addition of 25% of your new materials to make a new car. But that's not all. This the material reduction also goes hand in hand with a reduction in CO2 emissions during the lifespan, meaning from going from resource to scrapyard. And here we were further able to achieve a staggering 30% reduction over the life cycle. We're of course very happy that we achieved this goal, and it's been a hard and long road for us, to a lot of dedication, hard work to achieve this. And to highlight a bit about this process, we would like to also show you some pictures of how we've come there. So there I'd like to introduce Twan back to the stage Twan back to the stage to give you a bit more highlight about that.
Yes, thank you. Maybe you heard a small mistake. He called me Twan. There's actually a good reason for that, because we have two Tims within our team. And it became really annoying that someone would shout Tim throughout the office, and we would either both respond or either not respond. So that's why I've been dubbed Twan, and the other Tim has been dubbed Fort. If you want to know the story behind it, I would definitely ask Fort. He's sitting there on the corner of the first row. He doesn't like the attention too much, so here it is. But yeah, let's get back to the car. Of course, we also started on page 1. We had no idea how to build a car. Not even everyone in our team had a driver's license, so some people even never driven a car before. So how do you start? Well, it's really simple. You take a piece of paper and you just start writing down what's in a car. So we really started with just writing down a car has wheels. It's that easy to start. But it comes way more complex really fast. So on the left, something that you see is us trying out what do you need to do to actually make a car comfortable. So we just went into the garage, built a mock-up car out of old parts, and just tried out what is important for how you sit, what things are clashing, what do you have to take into account. And yeah, by just trying things out, we already learned quite a lot. And after the initial research, of course, it was time to design the car. So here you see our designers in the garage. This was a review session of a lot of sketches they made. A lot of time, a lot of iterations, and a lot of stolen printer paper went into this. This is just a fraction of all the sketches that has been made this year. But this is just a start. But one thing with the design we figured out quite fast is that we wanted a quite unique door design. So we looked at quite a lot of different mechanisms, a lot of inconvenient ones, a lot of really special ones. But in the end, we chose quite a special one. You will see it at the reveal of the car, so I'll keep it a bit secret. And here, you can already start to see the shape of the car. And from this point on, the designers really started to hone in on the design and really start perfecting it. So every curve probably had 10 sketches to make it perfect. But yeah, of course, the exterior of the car is not the only thing we had to design. we also had a lot of mechanical parts to design. This is a technical drawing of the chassis we made. We actually printed this out, hung it on the wall in the office, A1, really big. And sometimes when you came walking into the office and the chassis team thought you weren't looking, they were just sitting there, staring at the screen, staring at the wall, just admiring what they've made. So they're really proud of it. Definitely ask them how they did it and what was so special about it. The technical drawings in general were something that was quite new to us. It's not something that we learn a lot about at university. At least we thought we did learn a lot about it, but then we came to our first manufacturer and, well, they just started laughing because they could never make our designs. So this is something that we learned quite a lot about. This is the technical drawing of probably the most complex part in our car. And when we showed this to the manufacturer, they were actually quite proud because, well, usually they don't get to see this detailed drawings, and they were really glad. But of course, the mechanical parts isn't the only thing that you need for a car. You also have the electronics. Here you see Max, one of our electrical engineers, working on the PCB design. And the special thing about our PCBs is we have the same PCB used everywhere in the car. So if one of the PCBs breaks, which, well, in testing happens quite a lot, you can just swap it out for any PCB you have lying around, which allows us to actually, well, mass manufacture is a big word, but we can manufacture it in bigger quantities, which also reduces the cost, testing time, and, well, that makes our process really easy, relatively. And another thing we did to make the process easier was first build the entire electrical circuit outside of the car. This greatly reduced our time in integration testing. And here you already start to see a bit the shape of the car. So on the left top, you see the slot for the removable batteries. Right in the front, you see the stationary battery pack. Left in the middle, you see the batteries. So you already start to see the shape of the car, which is quite nice. But of course, in testing, not everything goes well. There are always some mistakes, and especially with electronics, finding mistakes is quite hard. With mechanical things, usually something just drops down or it breaks. With electrical, it's a bit harder. So it caused some headaches, but the extra time we had due to our smart way of working really paid off, which was quite nice. But then we actually get on to producing our parts. So here you see the welder busy putting our space frame together. It was actually made here in Eindhoven, so we could just cycle to the welding shop, which we did every day because we had like 10 massive technical drawings of it. It was the most complex part they've ever made. So they needed some help reading our drawings, which we were glad to deliver to them. It was quite an experience just being there all day, and also our chassis team learned a lot and it was a lot of fun. Which leads us to it actually being in our garage. And I think this was one of the biggest highlights of our year, because this really kicked off the building process of our car. We finally were able to assemble everything and we saw it coming together. And then we also got one other big part. This actually one of the windows of our car. As you can see with Luke as a reference, it's quite a big part. And we had to polish it fully to make sure that we could actually see out of it. But after a lot of hard days of work, this was in the middle of summer, so a lot of sweating, we were quite proud of the result. So on the left, you see the unfinished work, and on the right, you see the polished work. Massive difference, and now we can actually look through the window, which makes driving quite easy. Then, as you might imagine, the window parts are quite big, so we needed quite a special door frame for the windows. Here you see them assembling it for the first time. It's quite a piece of work. To make everything fit together with moving parts was quite a challenge. So a lot of adjustment has to be done. But this basically finished the first part of our building process. And the next picture, it's my favorite picture of the year. It's also the wallpaper of my phone. I like it so much. This is the first time the car was actually on wheels. So we immediately took it for a walk across campus. It was like driving the biggest, most expensive Skelter you've ever seen. Yeah, it was just an amazing moment, and we got it out just as the sun was setting. Yeah, it was like out of a movie. I also have a movie next for you guys of our other big highlight. This is actually the first time that our car was driving.
Lekker!
Yes, as you can hear, our event manager Imke was really excited about this moment, as you can imagine. But there's one thing missing here. That's, of course, the looks of the car. So that was our next big project, which was quite a stressful one. Because we arrived in the bouwvak, which meant that basically every company in the Netherlands was closed. So what did we do? We found a company in Germany. However, it wasn't that easy. We picked up the molds on Friday, and Monday we had to ship them out again. But in the meantime, we had to drill holes in them for the vacuum forming process, and we had to apply a coating. We've never done this before. The molds were probably one of our most expensive parts, so everyone was quite hesitant to attempt it. But once we actually got going, it turned out to be really easy, and we had worried for nothing. So it turned out to be quite a fun weekend. Here you still see us apply the coating. It's a bit of a toxic material, so we had to wear some protection. But yeah, everything turned out fine, especially when the first body panels actually arrived. Here you can see they're still quite rough. They don't immediately fit on the car. And you can see already a bit how they're formed. So basically, you have a blank sheet of plastic, and you just pull it over the mold, and then it cools down in the shape you want. But the shapes are quite complex, so this posed some problems with actually cutting it out. So we got a special tool for that, basically just a knife that goes up and down, and that's quite easy to handle, which, well, greatly reduced the time we spent on it. I remember the advice of our advisory board. They said, cut it out with scissors. Well, then we wouldn't have been here today because we would still be busy cutting out our body panels. So we're really glad that we took a little more time to research how to cut them out. We also had some 3D printed body parts. These were a bit more tricky because the material is way tougher and also way thicker. But as demonstrated here by our marketing manager, this was no issue at all for us. And I have one last picture for you guys for this evening, which is actually quite a special picture. This is probably the longest night we had this year. This was the day before the car had to be wrapped. As you can see, it's still black. It's not anymore. But we started at 9 in the morning, and we ended at 7, also in the morning. So we worked 22 hours consecutively to actually get the car done for wrapping. But we did manage to do it in the end. It was the only night that we had to work this long, so actually it was quite an experience, but I think I've never been this tired before. To finish off, we have one more small video as a summary of the entire building process. Yes, I have one more small summary for you guys. This is just in one slide what we achieved this year. So on the technical side, we have the modular batteries that have a normal range of 130 kilometers, and we can extend that up to 220 kilometers. And on the sustainability side, what we're most proud of course, is the 75% closed-loop recycling. And one small detail, but something that we really find special is we use less than 1 gram of glue in our car, which is insane to think about. We have an entire shelf of glue in our garage. It's really dusty. Basically, glue became the forbidden word in our team. And well, less than 1 gram of glue is quite acceptable. Of course, we couldn't have done this without our partner companies. Here we see an overview of them. You probably know a few names, but yeah, we couldn't have done this without their help, without our sponsoring, and without our consultancy. To give you a small teaser for the car itself, we have one more video prepared for you by the design team, and afterwards we'll head to Atlas, the building next over, and there we actually reveal the car and we'll have a drink together.
It is now 90 seconds to midnight.
I wanna share my dreams, wanna share with you on the wings of love, like dreamers do. Touch your heart, you're the queen of broken heart. Oh, we are daytime friends and nighttime fools. Wanna play this game, you break the rules. Tears of love are frozen tears.
Before we go to the final presentation, I would like to introduce a small moment just to thank everybody, but also especially a couple people in particular. We'd like to especially thank the board. So I'd like to give a round of applause and invite them all up here. Twan, Eduardo, Martijn, and Sylvia, come up here.
I didn't expect that.
No, I didn't know of it either.
It's been a rough year. There's been some really big highs and really big lows for us, but we've all managed to come through this thanks to you guys. You've guided us perfectly through this, and we'd like to present you with a small gift from the entire team, just as a thank you for everything. A nice picture with a personalized gift. Yes, come on, they deserve it.
Dank u wel. Echt leuk.
Did I have to pay for this?
Yeah.
Ja, goed.
And of course. So I don't want to keep you any longer waiting. Let's quickly go out to Atlas and let's enjoy for the car review. Thank you very much, everybody.
Leuk. Dank u wel.
I did make a video.
Tiago, I am so very happy about this. Okay, so when during the thing I was looking at the sketches,
Waar zit die in?
so excited about the
De andere speaker. Waar moet je
I'm really hoping you guys
Ja, doe maar. Doe je geen muziek? Ja, doe maar
It's kind of it doesn't
Ja, doe maar even muziek. Doe maar op je telefoon. Het is volledig. Oh, blijkbaar niet. Het is niet volledig dood, maar wel bijna. Waarom pakt hij nou het touw? Oh, nu doet hij het wel weer. Elevator music. Yes. Wat voor publiek hebben we nu? Iets open hier. Gewoon wat. Nou ja, je weet hoe het werkt. Ook zo omhoog verrekken.